Welcome to Tech and Trek, where we explore the past, powered by the future. I bet you didn't know how fleeting our footprint really is. Look around you. Our cities sprawl, our lights pierce the night, and our radio waves ripple through space. We leave our mark everywhere, from the plastic in the oceans to the satellites orbiting above. Our concrete jungles, for all their might, are fragile giants. Buildings crumble, metals corrode, and even the sturdiest structures eventually succumb to time. Much of what we create is ephemeral, destined to fade away like whispers in the wind. Think about the vastness of geological time. Our planet is billions of years old, and Homo sapiens, our species, has only been around for a blink of an eye in comparison. That's a lot of time for civilizations to rise and fall, leaving behind only the faintest whispers of their existence. The Earth itself is a restless being, constantly reshaping its surface through erosion, volcanic eruptions, and the shifting of tectonic plates. What was once a bustling metropolis could be swallowed by the sea, buried under layers of sediment, or thrust up to form the peak of a mountain. And with it, all evidence of a civilization's presence could be lost forever. But what about the things we leave behind, the artifacts and structures that seem so permanent? Even these are not immune to the ravages of time. Metals corrode, plastics degrade, and even stone succumbs to the relentless forces of weathering and erosion. Imagine a future archaeologist stumbling upon a rusted car engine or a fragment of a plastic toy. Would they recognize them for what they are, or would they simply be seen as curious geological formations? This brings us to a fascinating and somewhat unsettling question. What if we aren't the first intelligent life forms to grace this planet? What if, long before humans walked the Earth, another advanced civilization rose and fell, leaving behind only the faintest of traces? This is the central question posed by the Silurian Hypothesis. Named after the intelligent reptilian species from the science fiction series Doctor Who, the Silurian Hypothesis proposes that Earth may have been home to other advanced species, perhaps even technological civilizations, long before our own emergence. These hypothetical predecessors, like whispers from a forgotten past, would have lived and thrived millions, even billions of years ago. The challenge, of course, lies in finding evidence of their existence, especially given the vast stretches of time involved and the Earth's own relentless recycling of its surface. But what if we knew where to look and what to look for? What if, hidden beneath the Earth's surface or buried within ancient geological formations, lie the clues to a pre-human technological civilization? The Silurian Hypothesis compels us to confront the limits of our current understanding and to consider the possibility that we are not alone, not only in the vastness of the cosmos, but also in the depths of our own planet's history. Imagine a vast desert, dunes stretching as far as the eye can see. Now picture those dunes as representing the immensity of geological time. Each grain of sand is a year, a decade, a century. Our entire recorded history, from the first cities to the digital age, would occupy just a tiny pinch of sand at the very top of that immense pile. It's a humbling thought, isn't it? To realize just how fleeting our existence is on a planetary scale. We like to think of ourselves as masters of our domain, leaving our mark on the world, but in the grand scheme of things, our impact is surprisingly shallow. Consider the pyramids of Egypt, those enduring symbols of human ingenuity. For thousands of years, they've stood sentinel over the desert, enduring the elements and the passage of time. But even these colossal structures are slowly yielding to the relentless forces of erosion. Each gust of wind, each sandstorm, each downpour chips away at their surface, carrying away tiny particles of stone. Given enough time, even these seemingly eternal monuments will crumble and disappear, swallowed by the very desert they were built to defy. The Earth, you see, has a remarkable knack for recycling. It's a planet in constant flux, its surface reshaped and renewed through a variety of geological processes. Mountains rise and fall, oceans advance and retreat, and continents drift across the globe like giant rafts. This constant geological churn acts like a giant blender, grinding down mountains, swallowing up coastlines, and burying entire landscapes under layers of sediment. It's a process that's essential for the planet's long-term health, but it also makes the job of uncovering the past a monumental challenge. Imagine a city, bustling with life, suddenly engulfed by a volcanic eruption or swallowed by a rising sea. Buildings collapse, streets disappear, and the entire civilization is entombed beneath tons of rock and debris. Over time, New layers form on top, burying the old city deeper and deeper. Now, fast forward millions of years. The once buried city is now part of a mountain range, its skyscrapers transformed into jagged peaks, its streets compressed into thin layers of rock. Finding any trace of the civilization that once thrived there would be like searching for a needle in a haystack the size of a continent. The passage of time, combined with the Earth's relentless geological activity, creates what we might call the Great Erasure. It's a slow, inexorable process that gradually wipes the slate clean, erasing the traces of past civilizations like chalk drawings on a blackboard. Think about all the things we take for granted today. Our roads, our cities, our landfills overflowing with plastic. Now imagine all of it gone, reduced to scattered fragments or absorbed back into the Earth itself. Our most durable materials, like concrete and steel, will eventually succumb to corrosion and decay. Our plastics, designed to last for centuries, will break down into microplastics, infiltrating the soil and the oceans, becoming almost impossible to detect. Even our digital footprints, the vast amounts of data we store on servers and hard drives, are surprisingly vulnerable. Without a constant supply of electricity and maintenance, these digital repositories will degrade, turning our ones and zeros into an indecipherable digital soup. The Great Erasure is a sobering reminder of our own impermanence, a cosmic humbling that forces us to confront the possibility that we might not be leaving as lasting a legacy as we think. But wait, you might be thinking, what about fossils? Don't they provide a relatively complete record of life on Earth? While it's true that fossils offer invaluable insights into past ecosystems and the evolution of life, the fossil record is far from complete. It's more like a fragmented mosaic, with vast swaths missing, leaving us to fill in the blanks with educated guesses. The process of fossilization itself is a bit of a lottery. Only a tiny fraction of organisms that have ever lived are preserved as fossils. For an organism to become fossilized, a very specific set of circumstances needs to occur. First, the organism's remains need to be buried quickly after death, usually in sediment like mud or sand, to protect them from scavengers and the elements. Then, over millions of years, minerals in the surrounding sediment slowly replace the organic material in the bones, teeth, or shells, turning them to stone. But even when fossilization does occur, the vast majority of fossils remain hidden deep underground, locked away in layers of rock that are inaccessible to us. Only a tiny percentage are ever exposed to the surface through erosion or geological uplift, where they can be discovered and studied. The fossil record's blind spots. Now imagine trying to reconstruct the history of a civilization based solely on its fossilized garbage dumps and the occasional skeletal fragment. You might get a glimpse of their diet, their building materials, maybe even some hints about their social structure. But the bigger picture, the nuances of their culture, their beliefs, their technological achievements, would likely remain elusive. This is the challenge we face when searching for evidence of pre-human civilizations. The fossil record, while invaluable, is inherently biased towards organisms with hard body parts that lived in environments conducive to fossilization. Soft-bodied creatures like jellyfish or worms are far less likely to leave behind any trace, and civilizations that relied heavily on perishable materials like wood or textiles would be even more difficult to detect. Furthermore, the Earth's geological churn can play havoc with the fossil record. Tectonic plates colliding can shatter and scramble rock layers, scattering fossils like pieces of a jigsaw puzzle across vast distances and timescales. Erosion can wear away entire layers of rock, erasing millions of years of history in an instant. The result is a fossil record that is riddled with gaps, making it incredibly difficult to determine when certain organisms appeared and disappeared, let alone whether they developed complex civilizations. A cosmic perspective. Now let's zoom out even further and consider the vastness of the cosmos. Our planet is just one tiny world orbiting an average star in a galaxy teeming with billions of other stars, many of which likely harbor their own planetary systems. Given the sheer scale of the universe and the immense timescales involved, it's not unreasonable to assume that other intelligent civilizations might have arisen on other planets long before our own. In fact, some scientists believe that it's highly probable, even statistically inevitable. But just as we struggle to find definitive evidence of past civilizations here on Earth, detecting the signs of extraterrestrial intelligence across the vast gulf of space presents its own unique challenges. So, the question remains, are we the first and only civilization to have graced this planet with our presence? Or are we just the latest in a long line of intelligent beings, our own story intertwined with the echoes of those who came before? The Doctor Who connection. The term Silurian Hypothesis has its roots in science fiction. It draws inspiration from the classic British television series Doctor Who. This fictional concept sparked a real scientific inquiry. In Doctor Who, the Silurians are intelligent reptilian humanoids predating humanity. They hibernated underground to escape a catastrophic event. Could there have been other intelligent species on Earth long before us? Life on Earth has existed for billions of years. Humans haven't been around for most of that time. Is it implausible to think other intelligent species might have evolved? The Silurian hypothesis doesn't imply they were like Doctor Who's Silurians. They could have been entirely different in appearance and behavior. The vastness of geological time makes it a possibility worth exploring. The Silurian hypothesis wasn't just a whimsical thought experiment. In 2018, Adam Frank and Gavin Schmidt took this idea seriously. They explored if a technologically advanced civilization existed millions of years ago. They published their findings in a paper titled The Silurian Hypothesis. Their approach was grounded in the concept of the Anthropocene. They reasoned that a long-lasting civilization would leave a detectable signature. Subtle anomalies in geological and chemical records could indicate their presence. One of the key challenges in proving the Silurian hypothesis is that we're essentially looking for the shadow of the Anthropocene, a faint echo of an industrial civilization that existed long before our own. It's like trying to find a whisper in a hurricane, a faint signal buried under layers of geological noise. The Earth, as we've established, is very good at erasing the traces of past events. Erosion, plate tectonics, and the natural decay of materials all conspire to obscure the evidence. So, where do we even begin to look for these subtle clues? Frank and Schmidt suggested focusing on specific geological periods that coincide with unusual spikes in temperature or atmospheric carbon dioxide levels. These anomalies could be indicative of industrial activity, similar to the way human activity is currently impacting the climate. They also proposed looking for unusual concentrations of certain metals, like platinum or palladium, which are often associated with industrial processes. These metals are relatively rare in the Earth's crust, but are commonly used in catalytic converters and other industrial applications. Another intriguing aspect of the Silurian hypothesis is the concept of the technosphere, coined by geologist Peter Haff to describe human-made objects and systems on Earth. This includes buildings, roads, smartphones, and satellites, forming a complex layer that interacts with the planet's natural systems. If a previous civilization reached similar technological sophistication, they would have developed their own technosphere, leaving a unique signature in the geological record. Despite the intriguing possibilities, it's important to acknowledge the immense challenges in proving the Silurian hypothesis. Finding evidence of a technologically advanced civilization that existed millions or even billions of years ago is akin to finding a needle in a haystack the size of, well, the entire planet. The Earth's geological processes are constantly reshaping and recycling the planet's surface, making it incredibly difficult to find anything that predates the last few million years, let alone something as subtle as the chemical traces of an ancient civilization. Moreover, even if we were to find anomalies in the geological record, attributing them to an ancient civilization would be a matter of interpretation and debate. There are countless natural processes that can mimic the effects of industrial activity, making it difficult to definitively prove a technological origin. The Silurian hypothesis, therefore, remains firmly in the realm of speculation. It's a thought-provoking idea that challenges us to reconsider our place in the grand scheme of things and to acknowledge the possibility that we are not the first and certainly not the last intelligent species to inhabit this planet. When we imagine evidence of a past civilization, our minds often conjure images of crumbling ruins and ancient artifacts, or perhaps a forgotten city buried beneath the sands of time. The Silurian hypothesis doesn't rule out intriguing anomalies. Consider encountering oddly shaped formations, seemingly out of place. These could be unusual arrangements of stones, or metallic nodules with peculiar compositions. Approach such discoveries with skepticism. Nature is a master sculptor, producing intricate formations, but if we find a formation with geometric precision, it could raise eyebrows. While ancient structures may have turned to dust, their industrial activities could leave detectable traces in Earth's chemical makeup. Isotopes, variations of elements with different neutrons, are key. Certain isotopes link to specific industrial processes. Enriching uranium for nuclear fuel leaves a distinct isotopic signature. Analyzing rock layers can reveal unusual isotopic spikes. Natural processes can also alter isotopic ratios, so caution is key. Reading between the strata disruptions in the fossil record. The fossil record provides a glimpse into the history of life on Earth. It tells a story of evolution, extinction, and the rise and fall of species. Could it also hold clues to ancient civilizations? A technologically advanced civilization might have left its mark. Imagine a civilization mastering genetic engineering. Their activities could result in unusual patterns of speciation or extinction. The plutonium puzzle, a radioactive legacy of a bygone era. In 2014, scientists found high concentrations of plutonium-244 in ancient rock. Plutonium-244 is from supernova explosions, not naturally occurring on Earth. Its presence in ancient rock is puzzling. It might be from a natural nuclear reactor, like the Oklo reactor in Gabon. Earth's history is full of surprises, and we might not fully understand all its processes. The Great Filter and the silence of the universe. Are we alone in the universe? Despite billions of galaxies, we find no evidence of extraterrestrial civilizations. This is the Fermi paradox. The Great Filter might explain it, a barrier preventing life from advancing. It could be catastrophic events or self-destruction. Have we passed it, or is it still ahead? Perhaps the most significant challenge in proving the Silurian hypothesis lies not in the scarcity of evidence, but in the limitations of our own imagination. We tend to search for what we know, for patterns and artifacts that resonate with our current understanding of technology and civilization. But what if the civilizations that came before us were so radically different from our own that their technologies and artifacts are utterly unrecognizable to us? What if they mastered forms of energy manipulation or communication that leave no trace in the geological record as we know it? Imagine, for example, a civilization that harnessed the power of quantum mechanics or manipulated the fabric of space-time itself. Their structures might not be built of stone or steel, but rather woven from the very essence of reality, leaving behind no physical remnants for us to uncover. The Silurian hypothesis challenges us to expand our horizons of possibility, to consider that the universe might be far stranger and more wondrous than we can currently comprehend. It reminds us that our current understanding of physics, technology, and even intelligence itself might be but a pale shadow of what's truly possible. The Silurian hypothesis faces a fundamental hurdle in the scientific method: the burden of proof. Extraordinary claims require robust evidence. A pre-human technological civilization is an extraordinary claim. Scientists are inherently skeptical and demand compelling, falsifiable evidence. The burden of proof rests on those who propose such a civilization. One of the biggest challenges in searching for ancient civilizations is misinterpreting natural phenomena as technology. Nature is a master architect, creating structures that appear artificial. Concretions, for example, are mineral masses in sedimentary rock. They can be spherical or geometric, seeming man-made. Geological formations like basalt columns can resemble ancient structures. Just because something looks man-made doesn't mean it is. Time's distortion, the reliability of dating ancient events. Dating events millions of years ago is inherently difficult. The further back we go, the more uncertain our methods become. Radiometric dating relies on radioactive isotopes decay. Different isotopes have different half-lives, affecting accuracy. Even reliable methods are subject to error. Contamination and geological upheavals can skew results. The geological record becomes fragmented over time. It's like assembling a jigsaw puzzle with missing pieces. This is the challenge in reconstructing Earth's distant past. The Anthropic principle. Are we blind to other possibilities? The Anthropic principle, a philosophical consideration in cosmology, suggests that our observations of the universe are necessarily biased by the fact that we exist as observers. In other words, the universe must be compatible with the existence of observers, otherwise we wouldn't be here to observe it. While this might seem like a tautology, it has profound implications for how we interpret the universe and our place in it. It suggests that our understanding of physics, biology, and even intelligence itself might be limited by our own evolutionary history and sensory experiences. Could it be that our search for evidence of past civilizations is constrained by our own anthropic biases? Perhaps we are looking for signs of technology that are familiar to us, based on our own understanding of physics and engineering. while entirely missing evidence of civilizations that might have harnessed different forms of energy, manipulated different dimensions, or evolved consciousness in ways we can't even comprehend. The Anthropic principle serves as a humbling reminder of the vastness of the unknown and the limitations of our own perspective. It encourages us to remain open to the possibility that the universe is far stranger and more wondrous than we can currently imagine. A universe of wonder, finding value in the unknown. Despite the lack of conclusive evidence and the inherent challenges in proving the Silurian hypothesis, it remains a valuable thought experiment, prompting us to question our assumptions and expand our horizons of possibility. Even if we never find definitive proof of a pre-human technological civilization, the search itself has value. It forces us to confront the vastness of geological time, the cyclical nature of Earth's history, and the humbling realization that our own existence is but a fleeting moment in the grand scheme of things. The Silurian hypothesis also encourages us to consider the potential fragility of civilizations, including our own. If other intelligent species have arisen on Earth in the past and ultimately gone extinct, it raises profound questions about our own long-term survival and the challenges we might face as a technologically advanced species. Perhaps the most valuable aspect of the Silurian hypothesis is that it reminds us of the wonder and mystery that still surround us. The universe is a vast and enigmatic place, full of secrets waiting to be unlocked. While we may never have all the answers, the pursuit of knowledge and the exploration of the unknown are what make us human. A legacy of curiosity. The Silurian hypothesis, even without definitive proof, leaves an indelible mark on our collective curiosity. It serves as a potent reminder of the vastness of time and the humbling possibility that we are not the first, nor will we be the last intelligent species to grace this planet. This realization alone is a profound shift in perspective, urging us to reevaluate our assumptions about the past and our responsibility for the future. While the search for concrete evidence of a pre-human technological civilization might seem like a daunting, even impossible task, the pursuit itself is a testament to the boundless nature of human curiosity. We are by nature explorers, driven to unravel the mysteries of the universe and to understand our place within its grand tapestry. The Silurian hypothesis challenges us to look beyond the familiar, to broaden our definition of what constitutes evidence, and to consider possibilities that might seem outlandish at first glance. It reminds us that the absence of evidence is not necessarily evidence of absence, and that the universe is far more complex and nuanced than our current understanding might suggest. The unending search. The quest to understand our origins and to determine whether we are alone in the universe is a journey that extends far beyond the search for ancient civilizations on Earth. It encompasses a wide range of scientific disciplines, from astrobiology and cosmology to geology and paleontology, all working in concert to piece together the intricate puzzle of our existence. The search for extraterrestrial intelligence, or SETI for example, listens intently for radio signals or other signs of technological activity emanating from distant star systems. Meanwhile, astrobiologists scour the cosmos for exoplanets with conditions that might be conducive to life, searching for telltale chemical signatures in their atmospheres or faint glimmers of bioluminescence on their surfaces. Each new discovery, whether it's a fossil of a previously unknown species, a strange radio burst from a distant galaxy, or an unexpected chemical anomaly in an ancient rock layer, brings us one step closer to understanding the grand narrative of the universe and our place within it. The Silurian hypothesis, while focused on Earth's distant past, is ultimately a testament to this ongoing quest for knowledge, a reminder that the universe is full of wonders yet to be discovered, and that the pursuit of understanding is an essential part of what makes us human. Our place in the tapestry of time. Civilizations rise, flourish, and fade away, leaving faint echoes. This reminds us of our own civilization's fragility. We face challenges like climate change and social unrest. Our choices today shape the legacy for future generations. Let's strive for a positive and enduring legacy. Thank you for watching Tech and Trek. Don't forget to like, subscribe, and hit the bell icon for more explorations into the past, powered by the future.